I am Reddy. I am a plant physiologist. I am with the Department of Plant and Soil Sciences. I have been here for more than 34 years. We have only 2 such facilities in the country. We are proud to show you today. Follow me to our lab. I'll stop it here. I wanted to show you, we have what we call it as a sun-lit plant growth chambers. They are exposed to the sun, not artificially lighted. At time we have these plexiglass chambers where we can close it and then control everything inside. We can vary temperature from very low to very high like that, or we can create today's conditions or in the conditions that are projected in the future, something like 2050 or 2100. This is one of the 2 such facilities in the country. This is the first one that is built here in 1960s. I have the opportunity to work with the system for the last 34 years. Data that is generated here are used for developing models that can be used in the field conditions, and also the models also being used by other agencies like USDA. We have about 760 signals we monitor every 10 seconds. It is totally computer controlled. And follow me to show you about the interface between this facility into the computer system inside the building. So the heart and soul of the control environmental system resides inside the building. So we get about 760 signals coming from the outside, comes to this manifold and connected to the data acquisition control units. And then from that we have in-house built computer system. So we have in-house built program to monitor all the environmental conditions, all the variables that we monitor, how plant will respond to the environmental conditions. I am Reddy from Plant and Soil Sciences, and also I am Giles Distinguished Professor at Mississippi State. I am originally from South India, born and raised in family farm. I am the first generation graduate from my family. So growing up on the farm, all the things that like the aura that goes with the farming, producing our own food, intrigued me to work closely with the plants. I have been in the research for 45 years. Here at Mississippi State, I have been working for the last 34 years. I grew up with agriculture background, and then I was passionately interested in plants and natural ecology, those areas. So I got into that biology background, not in agriculture to start with, biology background, looking at how plants will respond to the environmental conditions. So when I had an opportunity to go and study abroad program, I had opportunity to go anywhere in the world. So I came to Mississippi State because of two things. One, it is connecting back to my roots. The second one is I have a Mississippi alumni who is a relative of mine who got a degree from Mississippi State. That's how I came here. The Plant and Soil Science Department has a comprehensive programs, both the teaching, research and extension, that addresses issues or problems related to agronomy, horticulture and weed science. So we integrate all those programs and then address the problems or issues and provide solutions to all those areas. For any faculty, it is the main thing is mentoring students and providing quality education, and then at the same time addressing the issues that are critical to the needs of the community, like farmers or producers or the stakeholders. Those are the issues that interest me a lot more than any other thing. I'm basically a plant physiologist. So I work with the multiple crops, all the crops that are grown in the state of Mississippi, including horticulture crops. So the main area of research is I work on crops that are how crops will respond to the environmental conditions, and then try to quantify those responses and try to develop tools or develop models, mathematical functions that can be used in improving the models or developing a new models for crops. The models are being used by the farmers or the producers of the farmers, but also used by the policy, other agencies for making policy decisions as well. Main area research focuses on the quantifying plant responses to the environmental conditions. So we have a unique sunlit plant growth chamber facility. We have only 2 such facilities in the country. So using that facility, we grow plants not only in the current environment but also in the future, like a 2050 or 2100 climate, and then try to see what crops can be, how the crops will sustain in the future climates as well. By doing that, we are trying to help the breeders to speed breed the process to develop like climate resilient crops that can sustain in the future climates. Last 30 years our goals are almost similar. Currently we are working on developing climate resilient crops, particularly on crops that are of global importance like rice, cotton, soybean and corn, and try to help the breeders to develop new varieties to sustain in the harsh environments that are projected in the future climates. The other component is we are also trying to design what we call it as designer crops, particularly for horticulture crops. When I came here, the fascinating thing at that time was developing a simulation model that can predict how a crop grows in the field. That is the out-of-the-box idea at that time. Even now, that is almost the out-of-box idea also, predicting something, how plants will grow in the field conditions. We're trying to improve those predictive capabilities of the models. So that is the most intriguing part of my research also. For the last 60 years, we made an impressive strides in agriculture. The rate of crop yield increased about 1.2%. Currently we are about 7.8 billion people globally, and then in the next 30 years, by 2050, we are expecting around 9.8 billion. That's more, 2 more billion people are going to be added in the next 30 years. What we need is not the 1.2% what we achieved per year, we need about 2.4%. So I am working a small piece in that puzzle to increase that productivity from 1.2 to 2.4% per year to develop crops that can produce the food that we needed to sustain the population. Crop simulation models, for example, it's the functional algorithms that we develop using our facilities here at Mississippi State are being used not on several agencies. Not only the farmers and producers they use it, but also other agencies across the board, even outside the country, they are being used to improve the functionality of the models to simulate how crops will respond to the climatic conditions. It's not easy for everybody to have these facilities that what we have. So the programs that is the reason we attracted so many scientists the last 30 plus years. We had about 40 visiting scientists. We trained almost like 16 PhD students in the lab for the last 20 years, and then 11 masters, about 5-6 undergraduate students. They came from all across the world, both the north, south, east and west, everywhere, within the country and outside the country as well. Developing the technology, what I earlier indicated is the simulation technology. It is multidisciplinary in nature. So it needs expertise from computer science to climatology to extension research and crops and soils and atmospheric sciences. So the challenge is to develop teams. That is where we face a lot the biggest challenges. Teams that can integrate all those technologies. Now we have other GIS, remote sensing technologies that could be integrated into the crop simulation models to make these models more resilient for applications. Mississippi State is blessed with, particularly in agriculture, with two to three different things. One is having plenty of water because of the alluvial aquifer that we have, and then the climate. So we can and we are growing crops that are of global importance. Rice is one of the main crop, wheat and cotton, soybean, rice, all those crops that we grow here. And then we have the resources to do that. Not every state has the water resources. We have those resources. If we do it more sustainably, then we will be the center of, in the future, water is going to be a major issue. So if we address those issues, we are the center for, become like a center for most of the agriculture productivity, including horticulture crops. We may become the hub for horticulture crops.